Okay, welcome back. So in the last video, we had a basic introduction to polynomials. We looked at the difference between a monomial, a binomial, and a trinomial. And now in this video, we're going to look at the degree of a term, the degree of a polynomial, and we're going to look at the key differences between like and unlike terms. Okay, let me pause the video. Okay, and here we are with the definition of the degree of a term. The degree of a term in a polynomial is the exponent of the variable, or if more than one variable is present, the sum of the exponents of the variables. If no variables occur in the term, it is called a constant term. And the degree of a constant term is always 0. Okay, now looking over here in these first three examples. In example A, we have 4x raised to the 8th power, or we could just say 4x to the 8th. That degree of that term is 8, again, because of the exponent that's on the variable. The exponent is 8, so that is the degree of the term. Then moving down to example B, we have 14x y squared z squared. Now, because this is one term together, we add the exponents together. So the x, being that there's no number there, we understand that to be a 1. So we have 1 for the x, and 2 for the y, and 2 for the z. So when we add all three of those numbers together, that equals 5. So this term has a degree of 5. And then moving down to example C, that symbol is pi. It does look like the letter N, but this is pi. And it has a degree of 0 because it is only a constant term. And by definition, if a term is only a constant, then the degree is automatically 0, as stated right here in that last sentence. Okay, now let's move down to the degree of the polynomial. Now, the degree of the term only is specific to the term, and terms are separated by the plus sign and the minus sign, or you can say addition and subtraction operators. But when you add them together or you combine one or more terms, it constitutes or it makes up the polynomial. So let's look at the degree of the polynomial. The degree of the polynomial with more than one term is the largest of the degrees of the individual terms. Now let me fix this mistake right here I made. So I'm going to fix this word largest. I'll be right back. Okay, there we are. It's fixed. So the degree of a polynomial with more than one term is the largest of the degrees of the individual terms. So let's look down here in these three examples. Example A, we have x to the 4th plus 2x squared minus 250. Now looking at the individual degrees, or looking at the individual terms, the first term in example A has a degree of 4. The second term has a degree of 2. And the third term is only a constant. So let's look back up here again. The degree of a constant is 0. So the 250 has a degree of 0. Now we're trying to find the degree of the polynomial. So we take the largest degree from each of the individual terms. And here in this case, the x to the 4th is the term with the highest degree. So this polynomial has a degree of 4. Moving down to example B, we have x cubed y squared minus 30x to the 4th. Looking at the largest degree from both terms here, we see that 30x to the 4th is that term with the largest exponent. So No, I'm sorry. No, it's not. It's actually the first term. The first term, we have x cubed y squared. And what we do is we add those two exponents. Those exponents add up to equal 5. And since that 5 is the largest of the two terms as far as the exponents, we use that degree and we say that is the degree of the polynomial. So example B has a degree of 5. Then moving down to example C, we have x cubed plus 3x squared h plus 3xh squared plus 3. Now, if we look at each term, they all equal the same degree because they all are raised to the third power. We have x cubed, then we have 3x squared h. And again, whenever a variable does not have a number up in the upper right corner, it is understood to be a 1. So 2 plus 1 is 3. And the same thing with x h squared. 2 plus 1 is 3. And then the last term also has a degree of 3. So the highest number is 3. And that is the degree for this term. Okay, now moving on along to the last section. Let's learn about like and unlike terms. Two or more terms are called like terms if they are both constants, which means they are only numbers, or if they contain the same variables raised to the same exponents and differ only, if at all, in their constant coefficients, which is just another word for the number, just a simple number in front of the variable. Those are called coefficients. Terms that do not meet these requirements are called unlike terms. Now, let's look at some examples of like terms. Looking here on the first line, we have 2x and 7x. They both are constants and they contain the same variables. 2 is a constant, 7 is a constant, and x is the common variable here. Now looking at the next pair, we have negative 14x squared y and 2x squared y. Now, these two terms contain the same variables, x squared y. So they are like terms. And finally, we have tu raised to the fifth and 6tu raised to the fifth. These are also pairs of like terms. And finally, moving down to the bottom, we have 4 and 4x. Now they may look like they're like terms because they have the same constant term, but that's not the definition of a constant. I'm sorry, that's not the definition of like terms. They have to have just a pair of constants with a matching variable, or only be constants with no variables. And so the first term has no variable, and the second term has a variable x. Therefore, these are unlike terms. Secondly, we have x squared, y squared. That's easy. They're different variables. Even though they're raised to the same exponents, they are still different variables, so they are unlike terms. And then thirdly, and lastly, we have a cubed b squared and a squared b cubed. Now, even though the same letters and the same numbers for exponents are used here, they are matched differently. The third power belongs to the a in the first term, but the third power belongs to the belongs to the b in the second term. So therefore, these are unlike terms. Now let me go ahead and write it right here. So I'm going to pause the video and I'll be right back. Okay, and there we have it. Pairs of unlike terms. So here we go. Again, I'm just going to do a basic little review of what we went over in this video. We talked about the degree of a term, which again, they are separated by operators, mathematical algebraic operators, the plus symbol and the minus symbol. So we learned about the degree, which is based on the exponent. And we also talked about the degree of a polynomial, which we take the highest degree from each of the terms, and we say that exponent, that number, is the degree of the polynomial. If we're just talking about the terms, then we simply use the exponent that is on the variable. Or if it is like in example B, where there's more than one variable, there's an x, a y, and a z, then we combine all of those exponents together, and that gives us the degree of that term. And then finally, we learned about like and unlike terms. Let's review this definition again. Two or more terms are called like terms if they are both constants. So if you have just two numbers, they're like terms, and you just add those numbers together. Or if they contain the same variables raised to the same exponents. That's why right here in the last part, these are not like terms because they are not the same variables raised to the same exponents. They are the same variables, but they're raised to different exponents. So be very careful with that. Okay, everyone, I'm going to stop the video right here. Thanks for watching. And if there is anything that I did not clear up for you, or you felt like I left you behind in some way, just leave a comment and I will respond to you. And I will be making more videos. So thank you and see you next time. Goodbye for now.